Okay, so what we're looking at is scatterplots using linear regression to find the line of best fit. We've drawn line of best fit before, right? We're going to write the equation. Okay, this first one, we have a little activity where we fill in the y values. Since we're doing all day with the quiz, we cut that out. So I'm going to give you some y values to fill in here. So let's just make up 2, 6, 7, 9, 11, 12, 13, 17. So fill in those numbers. Okay, so just like before, when we drew line of best fit, first thing we're going to do is we're going to graph all those points. Okay, you can number your graph here by ones in both directions, I think. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, going up, we'll go by 2, since that goes up to 17. So going across, we can go 1, 2, 3, 4, 5, 6, 7, 8. That's all we need to go to for the x's. And then we will count by 2's going up the y-axis. So 2, 4, 6, 8, 10, 12, 14, 16, and 18. Now on these, the smaller the number you can scale your graph by, the more accurate your equation by hand is going to be. In other words, it's kind of like an estimate of what we'll see. The calculator will give us the actual equation. Okay, so now I'll plot all those points. So 1, 2, 2, 6, 3, 7 would be halfway between 6 and 8 there. 4, 9, 5, 11, 6, 12, 7, 13, and then 8, 17 would be up here. Alright, once you got all the plots pointed, what we're going to do is the same thing we've done before. We're going to draw a line of best fit by hand. So this is one, everyone's might be slightly different. Remember, a line of best fit doesn't have to touch any of the points. It might touch some of them. So there's our line of best fit. Or my line of best fit. Yours might look a little different. Okay, so the line of best fit by hand, you're writing the equation of that line you just drew. Okay, so we need to know a slope and a y-intercept. Okay, it's going to be kind of an estimate since our line's an estimate. So for that line I'm looking at, my slope, if I say there's a point here and I'm going to estimate and say it crosses right there. That would be going up 2, 4, 6, 8, and then right 1, 2, 3, 4, 5. So I'm going to say my slope is 8 over 5. Okay, now for the purposes of this, since the calculator is going to turn it into a decimal, I'm okay with you making that a decimal. That way you can compare it. So 8 divided by 5 gives us 1.6. So I'm going to say my slope is 1.6. Okay, well, and then my y-intercept. Where does it look like mine crosses the y-axis? 2. Okay. Let me put 4 between those so you know those are the same thing. Okay, so there's a slope, there's a y-intercept. I can write an equation now in slope-intercept form of y equals 1.6x plus 2. Okay, so once again, since everyone's line might be slightly different, everyone's answer to that might be slightly different. You don't need to spend a ton of time trying to get it exact because it's an estimate to compare. Okay, so now here's the new part. In the calculator, we are going to use the calculator to do linear regression and enter this data and find out what the exact line of best fit is. So on your calculator, you're going to press the stat button. It's right below delete. And then hit enter on edit. So we've done this before where we enter our x's and y's. We're going to put our x's under L1, y's under L2. If you already got numbers there, you can just go highlight the top of the list and just hit clear and then enter. Avoid the delete button. Because remember, if you hit delete, it's going to delete that entire list. So our x's go under L1, 1, 2, 3, 4, 5, 6, 7, and 8. And then our y's are going to go under L2. 2, 6, 7, 9, 11, 12, 13, and 17. It's a good idea once you do that, just make sure you have the same number of terms in each list. Kind of tells you if you accidentally skipped a number or typed a number in twice. So if they're the same length, you probably got them all in there. And then you're going to go back and hit that same button again, hit Stat, and then use the right arrow and go over to this Calculate menu. Go over to Calculate and down to Option 4, Linear Regression. So we just hit Enter, and once that pops up on the home screen, you have to enter one more time. And it is going to give us the equation. We're going to round to 2 decimal places. So A is the same thing as M, it's your slope. So that means we have y equals 1.87, we'll round that to. 1.87x plus 1.21. So there is the exact equation of the line of best fit for that data. And you compare it to the one we did by hand, we're within 1 on both of those. Within, actually even less than that, like 0.27 for the slope and about 0.8 for the y-intercept. That's why the closer you can, or the smaller you can count by, when you scale your graph, the closer these two are probably going to be, because the more exact your estimate's going to be. Okay, so that's it. We're just going to do a couple more just like that. There's nothing new besides that. Okay, for the next one, for these years, we're just going to call this year 1, 2, 3, 4, 5, 6, 7, and so on to make our numbers a little smaller in the calculator. So if you want to fill in 1, 2, 3, 4, 5, 6, 7, and 8. So for our x-axis, can we count by 1s up to 8? Yep, so let's do that. 3, 4, 5, 6, 7, and 8. The y-axis definitely can't count by 1s, right? We got to get to 100. Probably not even 5s. 5, 10, 15, 20, 25, 30, 40, 45. No, 5s don't even fit. So we'll count by 10s. Try to keep it a nice even number. You can count by different than that, but it makes it easier if you count by something like 5s or 10s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So obviously now when you're graphing your points, we have 10 units between here and here. So it's going to be just putting it as close as possible to where it should be. So we got the point 132. So that would be about right there. 250. 363, so a little bit above 60. 475. 585. 692. 796, and then 100. It's pretty close to a straight line, those points. It has a little curve at the end there. So once you have those, draw your line by hand again. I'm going to say mine looks about like that. And then we're going to write the slope and the y-intercept of the line you drew. So yours doesn't have to be the same thing I have here. For mine, I'm going to say my y-intercept's at 30. And my slope, I'm going to say it's going up 10, right 1. So I'm going to say a slope of 10. So that gives me an equation of y equals 10x plus 30. Okay, so when we do this one in the calculator, it's not as likely that we're going to be as exact or as close to that line we did by hand, because you have to realize if we're counting by 10s between here, I could be off on my y-intercept just from here to here, and that puts me off by 5 units. Okay, so the bigger the numbers we have to count by on our scale when we're scaling the graph, the more likely this might be a little off. So that's okay. So So go back to your calculator. Hit those same buttons again. Stat. Enter on edit. So we want to clear out what we had there before. So go highlight the top of the list. Hit clear, enter. And enter your numbers. So our X's are 1, 2, 3, 4, 5, 6, 7, and 8. 7, 8. Y's are 32, 50, 63, 75, 85, 92, 96, and 100. And making sure you input those correctly is probably the most important part of this. So if you get them input correctly, it's going to give you the right answer. And then we go back to that same button again. Everything goes to that stat button. Hit stat again. Go over to the calculate menu and then down to linear regression. Hit enter, enter. So there's our equation. Round that to 9.56 and then 31.11. So y equals 9.56x plus 31.11. And we will all have the same answer for the part from the calculator because we're all using the same data for that. Okay, so it ended up being fairly close here. I got within a half of the slope, a little over 1 away from the correct y-intercept, which is actually really good when you're counting by tens up on one side. Good on that one? All right, 2 more on the back. Y'all do one on your own. All right, so for this next one, x's need to go up to 28. Can we count by ones? No. So let's see, 2s, 2, 4, 6, 8, 10, 12, 14. Nope, not even by 2s, so let's count by 5s. So 5, 10, 15, 20, 25, and then 30. And then going up the y-axis, probably can count by 5s again, up to 35. Yeah, we'll count by 5s again. So 5, 10, 15, 20, 25, 30, and we need to go up to 35 for the y's. So we're going to plot our points, get them as close as possible to where they would be. So 2, 5 would be about here. 4, 8. 6, 10. 8, 13. 10, 14, 12, 17, 14, 18, 16, 22, 18, 23, 20, 25, 22, 28, 24, 30, 26, 33, and 28, 35. So you kind of see there as you plot those, since we had to count by something bigger than ones in both directions, that you're just trying to get as close as possible where those points would be. It's very much so an estimate when you're graphing that. That was a lot of points. I'm going to give you all a minute to make sure you get all those written down. All right, so draw a line best fit by hand. So there's mine. For my y-intercept, I'm going to say it's about at 3. And for my slope, I'm going to estimate, say there's a point here and a point there. So that'd be up 5, right 5, which would give me a slope of 1. So I'm going to say, by hand, I'm going to say my equation is y equals 1x plus 3. and then everybody go to your calculator to make sure we can all get the same answer. So hit Stat, Edit, enter your X's under L1. And then your Y's under L2. Especially when there's this many points, it's easy to type one in wrong. So just take your time, make sure you get them entered all correctly. And what button do I press again? Stat. Go over to calculate. Down to linear regression. So enter, enter. So we get an equation of y equals 1.13x. So pretty close to our line by hand. And then y-intercept of 3.14. So there'd be my y-intercept. So you only need to really go back and check something to make sure you did something not incorrect. If you're way off by here, like let's say I had 10 here, might want to go check that again. Or if I had a slope of 1.13 here, but up here I got a slope of 5. Okay, if you're way off like that, then you might want to go back and see where we went wrong. All right, so I'm gonna have you do one of these over here under classwork. Then we'll check it, and then we'll go over the homework from last night and get to our quiz. So for this one, X and Y's, you can count by ones. Okay, so you only have to go up to 6 by X and 8 for the Y's. So start by numbering the graph.